All right. Hi everyone. For some reason, there we go. I'm back. Um, yes. People are speculating on what I have for dinner. No, It's actually just a bunch of chicken and vegetables and rice in a giant pot in the oven. Um, so it's super boring, but it's better than last night's dinner. So we're gonna get into environment setup now. Environment setup's a lecture that we kind of didn't used to have previously, but I wanted to add it because the biggest struggle students usually have at the start of the course is that they kind of don't know how to get set up. Um, so, so we're going to help you get set up basically. Now, the C++ environment, this isn't referring to like something universal. This is referring to like how to get set up in this course, if that makes sense. So it's very, 6771 specific. We want to get you familiar with Gitlab. We want to get you familiar with C++ compiling. We want to build the first program and then test the first program, basically. So, Gitlab. I just referred to Gitlab in the previous lecture, and we're just reminding you here that if you're not familiar with it, you can get familiar with it through Lab 0. Most of your work will appear on Gitlab already. We've already released Tute 1 and Tute 2 and are releasing Assignment 1 tomorrow, so you can check up on that. But we're going to compile our first program, and you can actually do this on the CSE machine. You can do this on most Linux machines. So if you have an Ubuntu VM or Windows subsystem for Linux, you can actually just do this straight away. And we're going to do it on VLab together, right? So I'm just going to open up two terminals here in VLab. And in the first one, I'm just going to make a file called file.cpp. And I'm literally going to take this and I'm going to paste it in here, right? Now, I know we haven't talked about C++ yet, but as you can see immediately, it looks very similar to C. What are the two differences you notice compared to C? Well, the first one is that instead of doing something like include studio.h, we're including IO stream. So IO stream is input-output stream, and it's effectively the same thing as studio.h, and that it's like, it's about input and output. It's just the C++ library of it. The other thing you'll notice is that instead of printf here, like maybe we'd say, hello world, we actually have this std : c out double arrow kind of thing, right? And we're going to get more into this later, but the short answer is for now that when you print stuff in C++, you actually do it like this. Now again, I'm not demonstrating the language to you just yet. I'm just trying to show you how to compile something really basic. And yeah, that's really about it. So like standard C out, and then these two arrows are kind of saying print it there. So if you want to print out more things, I could like print out another thing like hello. But again, we're not talking about printing right now. There's been a few questions in the chat about can you install stuff on Mac. You can do this on Mac, yes. You can do it on Windows. You can do it in lots of different systems. The thing about C++ is that it's a hardware-specific language. And that means that unlike Java and these other languages, which run in a virtual machine essentially, or the Java virtual environment, can't remember what it's called, JVM, is that it? Java Virtual Machine? I can't remember. I haven't touched Java for a long time. C++ runs on the hardware, and that means that like different systems will have different compilers and they'll behave differently and blah, 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 blah. So there's no short answer, but basically you can do this on different systems. I was just saying that you can do it on CSE and you can do it on Linux usually. But let's look at our first program here. Now, if I want to compile that, if I was to compile a C program, I would say gcc -o out, and then I would give it like file.c, right? Which says take file.c, compile it to a binary that says out, that's called out. With C++, it's actually really similar. I go G++ and then I say -o out to say that's the out, the name of the output binary I want is called out, and then I give it the file name, file.cpp. Then it compiles. And then when I do /out, it runs my program. And you can see in this case, it printed hello world, new line, and then hello on the new line, and then the terminal's kind of funny here because there's no new line. So I could go and add a new line there, and then compile it again, and then run it again. And that's like the basics of compiling and running a C++ program. Super simple. And remember how I said that C++ is backwards compatible with C? Well, I can show you this right here really quick. Printf hello. The G++ compiler will just compile that and run it. So it's all backwards compatible with C. Charlie says, can I do this course by using VS Code and SSH into the CSE system? Yes. I guess so. In general, though, I'd probably just try and set it up. I don't know. You can. There's whole different ways you can do things. It's really hard to support lots of different methods. So we generally support a Ubuntu install where it's done locally on Ubuntu, and we support a like a VLab install, and we might help with other ones, but generally speaking, like, you know, try and just dig on that on your own. And I'm sure students will post in the forum. Like we already had one kind student, I think it was Matthew. I can't even remember. Posted it somewhere. I pinned it. No, I didn't. Thought I pinned it. I'm so confused. Anyway, someone posted a very nice helping hand for Mac stuff. Maybe I dreamt it. Oh, there we go. Robert. I thought I pinned it. Yeah, Robert posted some stuff about getting it on Mac OS with a C line, which is a different editor to VS Code. I wouldn't touch that unless you're really confident with what you're doing. Cool. So, that's how you compile a C++ program. You can do things with .h files, just like you're probably used to. Like I can take this program here. I can make a file called age.cpp. I know the slides say .c. File extensions don't really matter, but it should be .cpp. Where I include iostream, which helps me print something. I include age.h, just like in 1511, and then I have a main file, and then I have my getAge function, which it calls. Like this is very C-like, right? And I could add another one, which is age.h, which just consists of this line here. Right, so this is like my function header or prototype, and then I can compile them same way, -o out age.cpp. Done, and then .run out. And there's my program, right? It just prints out the return value of getAge. So yeah, it's just very, very similar to C at the basic level. Now, you know this from courses like 2521. If you want to make your code more complicated in terms of compiling, you know, multiple files, it gets messy pretty quickly, right? So if instead of, for instance, having getAge in this file, I wanted to include it in another file, say I called this one like agelib, like age library, and this one just has this, and it also includes the header. Now again, I'm not explaining this because you should be totally familiar with this based on the prereqs that you're required to do for this course. Now I need to like compile my age.cpp with my agelib.cpp, and I'm using that .h file. So now when I compile it, I have to give it two files, agelib like this. Now this works, but suddenly you can see that the nature of compilation gets pretty intense, right? Because we're adding two more things. And then you can imagine very quickly this kind of gets out of hand. So the problem with kind of like the classic method of compiling that you're probably used to is that the second you have thousands of header files and CPP files, or hundreds or dozens because you're working on a real world project that's super big, it gets really challenging because there's a lot of dependencies to link. You have to make sure that they're linked in the right order. You could use make files, which again, a bunch of you have used before, but the problem is make files don't really scale too well. Like it's a pretty archaic way to improve things. So like if you've ever done an internship or you've worked at a lot of places, well, most places, you would have seen that they use some kind of build system, right? Like if you've used Java, they'll use something like Maven. C++ uses CMake, which is what we're using, and basically we're trying to find an automated way to combine lots of different files. Now you might be thinking, oh, well, in this course I'm only going to write a few files, so like it doesn't really matter, right? Well, sort of. But one of the key differences is that in a course like this, when we ask you to write tests, we're not going to get you to write them using asserts, like you might have done in, 2521 or something. We're going to ask you to essentially write them using a proper test framework, like an industry level test framework. And those frameworks aren't built into C++, right? You actually have to like install them. If you use like Python or JavaScript before, you have to add libraries, right? And then that gets complicated because with a language like C++, you have to add those libraries, and then when you compile with it, it just gets crazy. So that's why we use simple build systems. And to manage this build system for 6771, we're using CMake. There are other build systems, but CMake's just the one we've chosen. Now, this isn't a course on build systems. We're exposing you to it, but we're basically doing most of the work for you. But we're just explaining essentially like what this weird environment is you're working with. Now, I mentioned this about build systems and using CMake here and VS Code. But now what we're going to do is I'm going to do a quick dry run setup of the environment for you. If you've already done this, then like props to you. There's probably like 40 or 50 students that have done it, but this course has like hundreds, so I'm sorry for those who might be a bit bored for the next 10 minutes. Then we'll probably take a break after that, because I think we're at the end of the slides, basically. Yeah, so, but this little bit will take a sec. So to get set up with this course, and this is like, for anyone watching this is like the one thing you should do this week. Even if you're a Dropkick student who doesn't give a damn, this is like the one thing you should be doing this week, because like you need to get this set up to make sense of everything that's happening. You go to tutorials, you open tutorial 1. I can't click on it because I'm staff, but it's basically this here. And then this is what you do. I go to this GitLab page. I'm going to do this in VLab. Now, I understand some of you don't like using VLab. Totally fine. I dig it. Go set it up on an Ubuntu VM or a Debian or something we have given you in the instructions here in Setup Home. The thing though is, we expect everyone to have set it up on VLab anyway, because that's where we're going to be running it. So like it's important that you check that your code works on VLab, because C++ doesn't run in a virtual machine, it runs directly on your hardware. So you never know if something weird has happened. But also, like, if you can't set it up at home, you got to just do it on VLab. I couldn't work on my home computer is not grounds for like special consideration, right? Because you can always use VLab. Void says, how important is the debug feature? It's not very important. I wouldn't worry too much about it. Okay, so you open Shoot 1 and you go to setup.md. Now everything you need is in here. To complete this tutorial, we recommend you use UNSW's VLab, which I've already got up here. Blah, 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 blah. Now, it shows you the first thing, which is to clone it. So if I'm on VLab here, I'm just going to close one of these. I'm going to make a new folder called CS6771, which I've made. And then inside that folder, I'm going to go back here on the Shoot 1 page. I'm going to click clone. I'm going to copy this URL. And then I'm going to go to VLab. Why can't I go to VLab? I'm going to go to VLab. And I'm going to go git to clone, and then I'm going to paste that URL. Now, if you haven't added your SSH key to GitLab, or if you don't know what that means, you're going to have to go back to Lab 0 and have a look at it, right? Because that's kind of part of Lab 0. We're assuming that you're kind of set up on GitLab at this case, which is something most undergrads should be pretty familiar with. Ram says, is the font size set to 20 and every tutorial's VS Code on purpose? I don't know. I didn't actually make that config, but I'll take a look at it. So now we've done that first part. We've downloaded the tutorial repository onto like our system. Now it says, in your terminal, navigate to the directory you've cloned your repository to. Now what that means is that I have to now go inside the Shoot 1 folder, which has all the Shoot 1. You notice all the files here are the same as all the files here, because we've copied what's on GitLab to our machine. And then it says run bash this. So I'm just going to copy and paste it. I'm going to put it here, paste. I'm going to run that. It's going to go do stuff. My kind of head's in the way. I'm going to make my head smaller so you can see. I'll just move my head over here or something. Now I've already kind of done this little bit, so like it'll be a little bit quicker for me. But essentially it's going to do a whole bunch of stuff. Sometimes it like might wait a little while, like it may take a few minutes. You'll see a whole bunch of notifications appear down the bottom here, and they'll eventually disappear. Once they disappear, we ask you to close VS Code. You sometimes don't need to do this, but it's just safer if we tell everyone to do it. So you close VS Code, then the next step is to run code dot. Now code is the terminal command to run VS Code, and dot means this folder. So you're basically saying, hi VS Code, can you open your program with all the files in this current folder? So I do code dot. Now that all comes up. Now we say press Control-Shift-P, and then you select a kit, right? You start typing in CMake or CMake select a kit. So I could do that. I could do that here, right? I go Control-Shift-P. I just like select a kit, and then that comes up. I click enter, and then you'll see there's a whole bunch of things here. And I just choose the one that says COMP6771 because that's the one that was kind of installed in the previous step. So I do that, and then it did a little loady thing and updates. I just click later. I ignore those. Yeah, blah blah blah. The contents of the drop down, select 6771, and then we do CMake configure, and we press enter. So we do Control-Shift-P. CMake configure, press enter. Now you only have to do these steps here once per lab shoot, basically, or assignment. So it's like you don't have to like set this up every time you load it up. It's like for shoot 1 you do this once, for assignment 1 you do it once. You can skip some steps sometimes again, but like we're just keeping the instructions quite simple. It says generating done, so I go great, that's good. An output window should appear detailing the configuration process, blah 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 blah. Now that we've configured the project, we need to restart our editor and have our extensions pick up the new directory. So basically, because we've configured some stuff, we need to like reload VS Code. So I go Control-Shift-P, and I type in reload, and I hit enter. It refreshes everything, and then we're good to go. Super good to go. That was really easy. Now we're going to try and build a basic C++ program. Before we do that, let's have a little bit of a look at the folder structure. So inside of here, you can see that all of the code is sitting inside a source folder. So this is all shoot 1, and inside the source folder, you'll see that there's a whole bunch of little files. Now, if I open hello.cpp here, you'll actually see there's a really simple C++ program. Now, for this first lecture, I've decided to do the environment before we learn about the language, because I think with your C knowledge, even if you don't fully understand like this syntax, this program makes sense, right? Like it's a main function. It's got two numbers, you sum them together, and you get an output. The question is, how do we build this? Because like, sure, you can go to the terminal here and I can navigate to the folder and I can do what we did before where I say g++-o out hello.cpp and then I can run it. Great. But this won't work for lots of other cases. So we need to learn how to work inside this environment that we've provided to you. And to do that, we're going to follow the instructions. And it says, press Control-Shift-P, type CMake build target, and press enter. And then it says, you'll see a text box, type in hello x, which is executable, and press enter. This will build source/hello.cpp. Okay, let's try that. Control-Shift-P, build target, enter, hello x. Okay, it does a bunch of stuff here. It executes some command. It's building it. It says build finish with execode 0, which means success. How do we run it? Well, that's the next step. The first question that I want to answer is, how the hell did it know that that compiles that, right? Like, where is that configured? And that's configured inside of source/cmake lists. So in most folders in these projects, you'll see that there's a CMake list file. And this is basically metadata or instructions for CMake, so it knows how to compile your stuff. Now there's a whole bunch of detail here that you don't need to worry about, but essentially every time we make a new C++ file, we have to add an entry here. Now in a lot of the early labs and stuff, you don't need to touch these files, but I think it's important you understand them. So what happens is when we try and compile hello_x, it knows to try and compile this file for us. So for instance, if I make another file, I might open this one, make another file called hello2 in that same folder, and this one's going to be the sum of 11 and 15. I can't just compile that. I have to actually add an entry so that CMake knows how that's compiled. And I just want to stress you don't have to do this part right away. I'm just giving you a demonstration. So I would copy and paste that. I might call that hello x2, and it will compile hello x2. And then every time I update my CMake list file, I need to do a Control-Shift-P and reload. If this is a little bit fast for people, that's okay. I'm aware that this is being recorded, so I'm aware people can pause and stuff. That's why I kind of just move through things like clearly, but not like taking huge breaks. I need to reload it because until you reload it, the actual VS Code does not pick up what's in the CMake list file. And now I can do Control-Shift-P, build target, and then I can type in hello x2. And now that will build the other file. Now the question is, I've built it, but how do I run it, right? Because building's one thing, you know how to compile, but then you have to run your compiled code. And the next step here is now I'm wondering if I've got a mistake here. I actually think these two steps are kind of redundant. I'm sorry. I might have accidentally left them in. I added more instructions to this whole thing this term. I don't think you have to do this step. It's not going to cause you harm, but it's kind of like doing the... Yeah, don't worry about these two. I'll remove them from the tute. But the next thing to do to run the program is you basically navigate to where the binary is. So what happens is, this file here, hello2, is in the folder source/hello2.cpp, but I can run that by going to the terminal and simply running build/source/hello like this. So all the time, every time you build a C++ file, it basically builds it to like the same folder structure, just with build in front of it. So that's where all the binaries go. So when I run that, I get, oh, there's a hello x, sorry. Yeah. Hello x, because that was the name of the thing here, the target name. And then if I want to do the other one, I do hello x2, which we also built, right? So like we compiled those, and that's where CMake put them. It put them in that build folder there. That's the basics of like compiling. Like we make it pretty easy. You just, you know, if I want to compile like, and you'll do this for the lab, like the tute, sorry, with your tutor. If I want to compile cat, I just like do, you know, build cat, and then it builds, and then to run it, I just go to the terminal and I just type in like build/source/cat, and then it runs the cat program. Like it's very similar. There's just a structure to it. Kai says, where's the build folder though? I can't see it in your file explorer. Now, I will first preface my answer by saying I don't code in VS Code outside of the uni, because I'm a dinosaur, but I'm pretty sure that it might just be hidden because VS Code's aware that it's a build folder, which often people don't want to like play around with. Maybe it's because it's in the git ignore. I don't know. It'll be something like that. But basically, like, VS Code is somehow aware, I think, that it's not. Or maybe just not refreshed. That could be the other answer. No, I can't see it. What variable naming convention should we use in the course? Camel case or underscores? I'm pretty sure our style guide says underscores. There's a style guide on WebCMS 3. Pretty light style guide, to be honest. But we don't really mark convention in this course. Like, it's not like a first year course where we expect you to follow like all these specific conventions. Like, there's some things here, you know, like I wouldn't read this too extensively. It's like the kind of like, okay, when we mark your assignment, what we do is we auto mark it, we mark the quality of your tests, and then we do two pieces of manual marking. The first one is for your style, and I'll talk about this more tomorrow, but like the first one's the quality of your style, and the second one's like your C++ conventions. Now, your C++ conventions are basically us expecting you to use like modern C++ methods, not something that would have been written in the 90s and not something that looks like C, right? So that's like using the right function, and we'll explain that to you as we go. The style stuff, though, is basically like, were there comments? Did you apply consistency to your style? It's not going to be things like, oh, they used the wrong type of indenting, we'll give them 0. But there's more to say on that style topic. It's a lot easier than it sounds, but I want to save that till tomorrow, okay? Richard says, if we have problems using the editor environment, is it safe to just redo the installation and configuration steps? Yes, and if you run into problems with that, you can usually just torch everything. Like, you can usually just, like, start deleting tons of files. Like, you can just start deleting, like, .vs code and like, you can just start deleting everything, really. Like, if you have your actual assignment work backed up somewhere, or it's all in Gitlab anyway, then you can usually safely delete your home folder. I usually delete everything in my home folder about once a year. But back to Kai's question, why don't you need .build? I think that's an interesting question. I don't think that's a C++ specific question, but it's like, why can I run this? Now the reason that in earlier courses we expect students to do like hello this, like this, is because if you don't have that, standard terminal expects it to be an executable in a number of predetermined folders. But when you put this here, you're basically telling the computer, no, it's not an executable in one of the magic folders. It is like in this folder right here. The thing though is when you start a command with build/something, there are no like executables on Linux that have slashes in them. So basically, just by virtue of the fact that I've written like a folder structure here, Linux is like, oh, okay, this is not a command. Like, this is not a system command in the path somewhere. Yeah. Also, you can safely ignore a lot of these things. I just closed them. There was another question. Style guide's hidden. Is it? Did I make the page hidden? I'm sorry if I did. Oh, why can't you see it? Is the lectures repo hidden? Oh, no, I'm a bad person. Sorry. Yeah, sorry. Okay. Sweet, let's keep looking at the instructions. We'll take a break soon, and then we'll get into some C++ stuff. We have a lot to get through tomorrow. We'll probably have to go into next week, but it'll be fine. The last thing I want to show you, though, is just testing. In C++, we don't just have all these like C++ files like you're used to in C. We also have some test files. So for instance, I have this hello test file where we're using a test framework called Catch2, and this is the framework we'll use in the course. Now, you don't need to know everything about this framework. We will handhold you through some elements of it, but generally speaking, this framework allows you to kind of write C++-esque things and do things like asserts to check if things work in your program. So here's a very, very simple C++ program, and this string here isn't needed. Sorry. I have a test case. This is the name of the test case, and then what I'm doing is I'm making two ints, and then I'm checking if the sum of those two ints is equal to 9. Now, how do I run that test case? Well, as you can see here in the CMake list in that folder, I have a file here called hello.cpp. Now, I actually just realized that I think this is the one part of all the lectures I didn't sanity check. And it's kind of good because I can actually show you what's wrong here. But if I want to run that and make it work, I could do my standard, build, and I could do hello. And you'll see here, have a look at these little entries here. We have hello x, we have hello x2, and then we have this one up here, hello. And it's in build/test/hello. So VS Code is aware of all of the targets, all of the potential compiled pieces of work that might be named hello. When I click on that, what happens is it will try and compile it, and it's probably going to fail. You can see it's like doing some stuff here. Sometimes it's slow. Oh, it worked. Why did it work? Didn't think it would work. Oh, I kind of know why it worked. Okay. Anyway, okay, I did check this one. There's one thing I didn't check. It'll find me. Fireson says, where is catch2/catch.hpp stored? So we're including catch2/catch.hpp. Now, what I want to kind of explain to you is that in C, you've done things like include std.ao.h. Where is std.ao.h stored? It's stored somewhere in a library. Do you know where it is? No, you don't. Could you look it up? Probably. Does it matter? Not really. Catch2/catch.hpp is the same thing. The difference is we had to download that library. It's not core to C++. It's like a pip3 install or something, right? It's something extra. Now, the reason we use programs like CMake, or sorry, build systems like CMake, is that CMake is able to like download this for us. And compile with it for us. Like, we don't need to do a ton of work. Now, you don't need to understand how that works. There's all this stuff here that makes it work that you don't need to touch. But the point is, catch2 is not part of like if you took this code, like just to show you, and you tried to just like compile this on CSE's machine, like you were like, hello, like you can, you know, sad.cpp, and you just like pasted this in, and then you just like did g++ sad.cpp, it would just be like, what the hell is that? I have no idea what that is. So that's why we use build systems, because it allows us to make more complex code and do it in an easy way. But this is how you write a test file. Now, test files are just normal executable files, right? They're built, and then you can run them. And they're a lot like what you would have done with asserts. It's just this is a bit more advanced. So we have things here like, you know, this is a test case, and then we do checks. And we might do other checks, right? Like we can check that it's not equal to 5. That's a stupid check, but you know, we could do that, and then we could build it. And then how do you run it? Well, you can run it a similar way to what we did before, where you go build/test/hello, like that, and it'll say all tests passed, right? Running asserts essentially in the background. And that's kind of how you do a basic test file. Now, someone's asked in the chat, what's the difference between an HPP and a .h file? Nothing. I think .h is the general convention. I think most I think it's .cpp for C++ files and .h for the .h files in C++. Though I think you'll see .hpp somewhere. I don't think like one is terrible. I think .h is more generally accepted, I think, from what I understand. We can also actually run all of our tests, I think. I'm not going to get more into this bottom part. You can play around with that yourself, and we can maybe chat about it later. But there's a shorthand where you can also do Control-Shift-P. Anytime you see this menu come up, I've typed in Control-Shift-P, and you can actually do run tests, which I think will compile all the tests and run them. Not sure. Yeah, I think it compiles all of the tests in the folder. Like you can see here, it's compiling the sort3 test and the hello test. These are the two main tests, and you can see that it ran them all and they all passed. So if you want to, you can just write run tests, and it will compile all the tests. How does it know that they're tests? Well, if you actually go look at the CMake list file, notice how all of the .cpp files we had that were just int mains, they were cxx, as in C++, executable. Whereas if you go to the test folder, notice that in here, the two tests are written cxx test. So if I change one of these to executable, it wouldn't work. Your tutor will hopefully talk more in the tute about linking files and stuff. Essentially, like, the last comment I'll make before we take a break is, like, you're familiar that when you... Like, remember how we did that install before where we had to, like, compile two programs? It was, like car.cpp and carlib.cpp or something. That's a process called linking, where you take two files and two compiled pieces of code and you link them together. You actually have to do a similar thing in the CMake list file here, where like if you have like a test file that is compiled with another CPP file, you have to link them in the CMake list. Again, you don't have to do any of this because we've done it for you. I'm just explaining it because I think it's a common headache we have for students, is they're like, I don't understand what's happening. Since there's no kind of backlog of questions, let's take a 5-ish minute break till like 7:16 or something like that. And then we'll get into the C++ basics, which will keep us busy tonight and tomorrow night. But that's pretty much it on the environment setup. So thanks, everyone.